Good morning, students. Today we can discuss the next topic of the chapter application of derivatives, that is increasing and decreasing functions. Increasing and decreasing function. Okay, what do you mean by increasing and decreasing function? You see, we can take I be an open interval contained in the domain of a real valued function of f. That means we know for a function, domain and range are there. The x1 values are in the domain and its image f of x values are in the codomain or range. See, in the closed interval I, if x1 less than x2, see the change? x1 is less than x2, then if x1 is less than x2, x1, x2 are in the domain, then f of x1 is less than or equal to f of x2. If x1 is less than x2 and the change of their images, see f of x1 is either less than or equal to f of x2, then we can say that the function is increasing. What is it? The function is increasing. That means for increasing function, no need of the inequality symbol greater than. Okay. The symbol greater than doesn't mean the function is increasing. The function increasing means both x and f of x. Both x and the image f of x have the same change. And here x1 is less than f of x2 and whose image f of x1 is also less than or equal to f of x2. The same change. Increasing means the same change, not the inequality greater than. Okay, if x1 greater than x2, then f of x1 is greater than or equal to f of x2. The same change means increasing. Or if x1 less than x2, then f of x1 is strictly less than f of x2. Not less than or equal to. It is strictly less than f of x2. Then we can say that it is strictly increasing. If x1, not the point, if x1 is less than x2, then f of x1 is either less than or equal to f of x2 means it is increasing. If x1 less than x2, then f of x1 is strictly less than f of x2 means it is strictly increasing. What is the difference between increasing and strictly increasing? Listen, I will show you an example. This is a graph, x-axis, y-axis, the function. One function like this. Okay, yes. And I will show another function. See, this function here, this function in each value of x. For example, if we take x equal to 1, then f of x is 1. X equal to 2, f of x is increasing, 1 point something. X equal to 3, f of x increasing. The last point, again, x is increasing. That means, in each point, f of x is also increasing. That means, the function is strictly increasing. Okay, in each and every point of x, the image is also increasing. Then it is called strictly increasing. See, second graph, in first point, okay, here it is increasing. But here it is decreasing, again increasing, decreasing. Okay, and finally it is increasing. Okay, not in each and every point, finally the function is increasing. Then it is called not strictly increasing, it is simply an increasing function. But here this is an strictly increasing function. You got the point? Okay. Then what is decreasing function? Can you say what is decreasing function? Yes, decreasing function means if x1 less than x2 in the domain, x1 less than x2, then f of x1 is greater than or equal to f of x2, not the same change. It is opposite change. Okay, the image and the value has opposite changes. It is called a decreasing function. Okay, decreasing function. And if x1 is less than x2 and f of x1 is strictly greater than f of x2, it is called strictly decreasing. It is called strictly decreasing. Then I will show a graph for decreasing and strictly decreasing. See. Yeah, similar to the previous one. See, this is strictly decreasing. How it is strictly decreasing? Yes, the first point, it is 5 or something. The next point, decreasing. Next point, decreasing again. Okay, that means each and every point of x, the image f of x is decreasing. That means it is strictly decreasing. You got the idea? Then see, another graph we can draw. See, it is decreasing, constant, increasing, decreasing, constant, then finally it is decreasing. Okay, and each and every point of x, the image is not always decreasing. Sometimes it is constant, sometimes increasing, but finally the last point, the function is comparing to the first point, it is decreasing. That means it is decreasing, simply decreasing. But here the graph is strictly decreasing. You got the difference? Yes. But by using this definition, we can't do the problem. Okay, in problem, we are using another definition. See, in the closed interval AB, if the function is decreasing, not the point, in closed interval AB, if the function is decreasing, then f dash x is less than 0. That means negative. If the first order derivative f dash x is negative or less than 0, it is decreasing. And if f dash x is greater than 0, it is increasing. And if f dash x is equal to 0, neither negative nor positive, it is a constant function. Okay, we are using this definition to solve the problem. What is the definition? In the closed interval AB, if the function is decreasing, the first order derivative f dash x is less than 0, negative. If it is increasing, then f dash x is greater than 0. If it is 0, means it is neither increasing nor decreasing. Okay, we can discuss one problem. See, f of x equal to 3x plus 70. Check whether the function is increasing or decreasing. What is the method? Yes, find f dash x. F dash x. 3x. What is the derivative of 3x? 3 into 1. Derivative of 17 is constant 0. 3 into 1, 3 plus 0. 3 is greater than 0, a positive quantity. F dash x is positive. F dash x is positive means it is increasing. We can write the function is increasing. Is it clear the method? Yes. See, f of x equal to sin x, the trigonometry sin x. F of x equal to sin x. Okay, you have to explain whether the function is decreasing or increasing in the interval 0 to pi by 2. In the interval 0 to pi by 2. Pi by 2 means 90 in the first quadrant. What is the method? Yes, find f dash x. What is f dash x? Derivative of sin x, cos x. Okay, f dash x is cos x. In the first quadrant, all trigonometric ratios are positive. Then the first order derivative cos x is also positive. We can easily say that the function is increasing. Then what about in the second quadrant? Pi by 2 to pi. A second quadrant. Okay, in second quadrant only sine and its reciprocal cosec are positive. In second quadrant, if the first order derivative f dash x is cos x is negative. In second quadrant, cos x is negative, less than 0. That means in second quadrant, the function is decreasing. You got the idea? For proving the function is decreasing or increasing, the method is find the first order derivative f dash x. If f dash x is positive, greater than 0, it is increasing. If f dash x is less than 0, negative, it is decreasing. And if f dash x is neither positive nor negative, we can say that which is neither increasing nor decreasing, which is a constant function. Is it okay? And similar, many problems are there in exercise 6.2. We can do the question one by one. Okay, thank you.